Hello again. So yes, a few changes. And this is, just a really quick overview of something that we looked at again a few years ago in one of our workshops. And I guess I have the clicker, so here it is. And here's again the picture. And you can see, in this case, a lot of the same characters. In fact, I noted that two of the folks who like to get in the back row and stand on things so that their heads are apparent above everyone else seem to be doing that in this picture again. But this is just another example of how over the years the Explore Mars, Achieving Mars workshops have really done some really good work. And again, I'd reference, for anyone who's interested, go on the website and you can find all of these reports. This particular one came out of an architecture-focused workshop that we were doing. And we ask ourselves the question, what is achievable if we really wanted to do something in the 2033 very favorable opportunity that we have between Earth and Mars? And so we looked at that, and this is the result of that. And then a subsequent paper that Hoppy and some of his colleagues did that I'll reference. So here we go. So what we took out of AM5 was this configuration that you can see here on the screen. We assumed a lot of things were available, including Orion. You remember this morning in our panel discussion, we talked a lot about that transit hab, and that was what Hoppy described to you this morning. A little bit of malice aforethought there on my part, because that was something I knew we were going to want to have in this case. So that's the real key thing that we really ought to be doing if we wanted to do something and take advantage of this 2033 favorable opportunity. If we had a transhab, and you can see it there, each of these elements on the screen, you'll note down below there, we've put a reference, and I noticed it got a little messed up when I went to the PDF, I think. But you can see the metric tonnage of each piece, and I'll show you the launch strategy in a moment here too. But the transhab is about 45 metric tons, and it's similar to what Hoppy described this morning in terms of keeping a crew of 4 comfortable and happy and healthy on their way out to Mars. Now, a key thing that Eric mentioned this morning was that human health is dramatically affected by the total time and the duration, because obviously you're exposed to the radiation, the microgravity, you can get a toothache. All those things can go wrong the longer you're out there. So what we were taking, trying to take advantage of this very favorable opportunity in order to bring that into a time frame that we were comfortable with. And that's about, roughly a year and a half, because we've had people on the space station for, year-long missions and things like that. So I put this together. This is an update that, as I say, Hoppy and some of his colleagues did, and actually got written up in the Journal of Spacecraft and Rockets. I put the reference down there at the bottom of this chart. And again, this basically took our concept that we came out of AM5 with, added a few things to it. But the key points really are that we had, all near-term technology, no new technology developments required, some assembly in orbit, but no propellant transfer. And a bonus, we get a twofer, because on the way home, we actually have to fly inside the orbit of Earth. So we can not only send a crew doing a flyby of Mars, but also of Venus. So you talk about an inspirational mission that could happen in the 2030, early 2030s to mid 2030s. And again, only using technologies that are fully developed and elements that would, the transhab being the main one, that would have to be kind of accelerated a little bit and brought into the flow. It would be launched in segments by SLS and different commercial rockets. It could be assembled in either high Earth orbit or at the gateway. And the crew then could come home to Earth once the mission was over, directly in the Orion capsule. And as I said before, it's a very unique short-stay orbital mission of about 1.6 years total duration. It also gives us a pathfinder for a lot of those systems. So it's not really just a stunt or a one-off. Here's the kind of bat chart that just shows the overall mission and how we would do it. So again, it's a mix of commercial and SLS launches. You can see the 4 SLS launches there shown across the bottom. We launch the bipropellant stages up on commercial launch vehicles, and those are assembled there in the low Earth orbit, used to boost to trans-Mars injection, and then used out at Mars for Mars orbit insertion. And then the trans-hab itself and some of the other major large pieces are launched in addition with the crew there on the 4th SLS launch. And then you can see the transit times shown there. You spend about 30 days, then after MOI, 30 days in the vicinity of Mars, you come back as you fly by. You've got a total round trip time of about 570 days. And as I said before, you actually get to have a flyby of Venus as well. And then come home in Orion for direct entry to Earth. So overall, 15 low-cost conventional hypergolic propulsion stages could be designed to be mass-produced with just simply kind of varying tank sizes, and no in-space cryo, no propellant transfer, using Orion, using SLS already, and potentially using Gateway as an assembly point. So again, what do we need? We need that trans-hab to make this a reality. And there it is on my first bullet of my last chart. Main need we need is the transit habitat. All this storable stage design is very similar to the upper stages that we've already built for other rockets. We'd need to build a few of them. That's actually probably a good thing because that's a cost savings. We've got the engines. We ourselves have them, and so do other people. But they're very high TRL engines. And you can launch on existing launch vehicles, and you can certainly take advantage of Orion as well for the crew. So no technological breakthroughs required, provides us with a pathfinder, an inspirational mission, takes advantage of the unique 2033 opportunity. And it turns out it also would work in 2035. In fact, just hallway discussion with Hoppy this morning, he was telling me that actually 2035 is a little bit more delta V on the way out, but actually I think gives you some benefits in terms of the overall trip time, and you don't necessarily need the Venus flyby, I think, Hoppy, is what you told me.
The Venus flyby, no deep space maneuver.
That's right. No, that's what I was. Yeah, it eliminates the need for some of the deep space maneuvers. So we could probably save some delta V out in the latter part of the mission. So that's what I had for you in the lightning talk. And if anybody has a question, I guess we have 1:30 left, so feel free to come on up. All right, great. Well, if we don't have any questions, then I'm going to go ahead and get us a little bit more back on schedule. So it's my great pleasure to introduce our next panel, or the moderator for our next panel, is Dr. Hakeem Olushedi, and he will come out and introduce his panel.